Okay.
How we doing, guys? Last section.
Last
right?
section.
Chapter 12. So last section of
For a while.
yeah.
Because we'll go to
Yeah,
reviewing.
we're gonna review for some testing and so on, and so
Yeah.
I'm gonna take a little bit of a break from the routine for a couple weeks probably.
Yeah. Yep.
So, so we're looking at volume and surface area.
Yep.
Of
all at
spheres.
once. Yep. Pretty easy.
Yeah, and so I don't know if you're remembering the specific definition of a circle, but the definition of a circle is all the points in a plane, and that's very specific, in a plane that are the same distant or equidistant from a given point, and that given point is the center. Well, if we take away in a plane, if we say all the points that are the same distance away from a specific point and make it three-dimensional essentially, that creates a sphere. So if you think about a circle kind of spinning in space, that would create a sphere. A sphere is just a ball.
Yep.
So, but the more technical term is a sphere. And really, we're not changing a whole lot.
Nope.
We're plugging into formulas still.
Yep.
And
I mean, it's
just
pi r squared's right there, and then
Yeah.
just 4 of them.
yeah. Some of these are kind of odd how they came up with these formulas, but they're
Yeah.
just formulas to
Yep.
plug in. So, and so yeah, that's the formula for the surface area of a sphere. And it's kind of weird to think about the surface area of a sphere, but this is a pretty good illustration here of the leather, although it kind of gets doubled up a little bit, but the leather for covering a baseball and how much material that takes to be able to do that.
But you can definitely see the 4 circles on the ends there.
Yeah.
And then that is just 4 pi r squared kind of. I see it really well with that when I look at that picture too.
Yeah, that's true.
You know.
So yeah, so that's their formula, and so we're just going to look at an example, I believe, here of they're going to give us a sphere with a diameter of 40 feet, and so of course that makes the radius 20 feet, and they want us to find the surface area. So all we do is put the 20 in for the r, square it, and multiply it by 4 and pi, and we're going to get 1600 pi square feet. Now again, that's an exact answer. If you needed to round that off to whatever level, then you could plug that into your calculator and get that rounded off. But really it's just a matter of plugging in the radius and squaring it, multiplying by 4, multiplying by pi.
I think they do give the approximation.
That's the surface area.
Yep.
So they plug it into a calculator and get approximately 5,026 and a half square feet for that. So that's a large sphere.
Yeah.
Diameter of 40 feet. That's a big water tank or something. Surface area, SA stands for surface area. The surface area is 30 pi. This one's going backwards now. Surface area is 30 pi for a sphere, and so they're giving us the surface area. They want us to find the radius, so they're going to have us go backwards with the formula. And so we're going to take that 30 pi and plug it in for the surface area on the side. The formula for the surface area is 4 pi r squared, so we're trying to solve for r. So there's a 4 in the way that's being multiplied. There's a pi in the way that's being multiplied, so we're going to divide by both of those and get 30 pi over 4 pi. The pi's will cancel. 30 over 4 will reduce to 15 over 2, and that's our r squared. So to get r by itself, we're going to take the square root of both sides. Slide here, they've done a couple steps in one. They've taken the square root of both sides, which would be radical 15 over radical 2, but then we can't leave that radical 2 on the bottom. We've got to rationalize. We're going to multiply top and bottom by radical 2. So on top, that's where the radical 30 comes from, is radical 15 times radical 2. Stays all underneath the radical. On the bottom we get a radical 2 times radical 2, which is radical 4, which square root of 4 is 2. And so we end up with radical 30 over 2 units for the radius of that particular sphere that has a surface area of 30 pi. All right?
Yep.
Approximated to be 2.74 units. So if you were to plug that into your calculator.
All right, and so then if we go to volume here, guys, if you look at volume here, I mean, it's pretty much almost the exact same thing as surface area, except instead of 4 pi r squared, the radius goes up to cubed instead of squared, and we divide the 4 by 3, or divide the whole thing by 3. So, I mean, it's almost the exact same formula, but for volume we just change it a smidget. Mm-hmm. You know, and a good thing to remember that I like to look at is the radius is up to 3, and then you're dividing by 3. So the 3 repeats itself if you're having a hard time remembering, you know, is it squared, is it cubed, or whatever.
Right, and the cubic just comes from all of our volume formulas have been cubic. Everything
Yep.
in volume is measured in cubic units, and so.
Yeah, so in order to make your radius three-dimensional, you've got to cube it.
Yep.
Okay, so I mean, it's just pretty straightforward. Write it down, remember it, and then all you got to do is kind of plug things in. So right here, the radius of a sphere is 5 yards. Find the volume. Okay, so all I'm going to do is I'm going to go 4 over 3 times pi times 5 cubed. okay? And there it is right there, 4 over 3 times pi times 5 cubed, which comes to exactly 500 over 3 pi yards cubed. And then all I have to do is simplify that, so I go 500 divided by 3 times by pi, and I get approximately 523.6 yards cubed. I mean, pretty straightforward here. I mean, I don't.
Yeah, it's just a formula. We're just plugging into formulas.
Yeah,
just
you know
because
radius.
You understood the formula and what it represents.
Yeah, I mean, radius is the only thing that's ever unknown here.
Right.
You know, or the volume itself. And so, if you know one or the other, you just plug those in and then go backwards or go forward, and from there, and you're in good shape.
Solve for the unknown.
Yep.
Yep.
So if I have this composite shape here now we got to combine two ideas. Okay, we have to combine a full sphere, okay, because the left side is a half of a sphere and the right side is a half of a sphere, and then the cylinder in the middle. So we've got a sphere plus a cylinder. So we're going to have the formula for the sphere, which is 4 over 3 pi r cubed, plus the area of the volume, of the cylinder, which is pi r squared times the height. Okay, so once again, all you got to do is plug things in. The radius is 2, so instead of r cubed, I'm going to have 2 cubed, and then the height is 7, and then for r squared, you just plug in 2 squared, so it looks a little bit like that. So I have 4/3 pi divided by, or times 2 cubed, plus pi 2 squared times 7 for the height, and you get exactly 116 over 3 pi centimeters cubed, or approximately, oh, it doesn't give us the approximation.
Well, because these
Oh, it says
instructions say
exact.
to find the
Thank you.
exact.
Yeah.
And so they left it as pi.
So, yeah, so you're done
pay
there.
attention to the instructions there, guys.
Yeah,
The others are
there's that.
estimating, and this one's exact. So remember, exact means leave it in terms of pi. So
One thing here about surface area that's different than volume, notice that if it would have been surface area, we wouldn't have used the tops, we wouldn't have been able to include the tops of the cylinders when we
That's
do
true.
when we do surface area. But
right, because they're
for
covered up with the sphere.
yeah, but
Yeah.
for volume, guys, remember it's everything we can fill into that whole entire shape.
Right.
So we take the complete formulas of each whenever we do volume and composite shapes. We always use the full formula. We're not cutting anything off.
Yeah, if you're filling that thing with water, it's the whole thing that you'd fill up. So
Now, what's the formula for a half sphere, Mr. Scritchfield, if we wanted that?
for the volume,
Yeah.
well, you just put a half in front of this, which would end up making that a 6 on the bottom instead of a 3. And so you could just change that to a 6, and it would be half of a sphere.
So it'd be 2/3 pi r cubed.
You could do that too.
Yeah.
Once reduced, yeah.
Yeah, I mean,
Yeah.
the only reason why I bring this up is I know in the book
There are some
the
examples
questions
of-
that have you do a half sphere, and
Right,
so didn't
right.
even throw you under
What's
the
that?
bus
What's
right
a
there.
half sphere?
Half sphere is half a ball.
Right. Called a hemisphere.
Oh, hemisphere. I knew that too. See a little bit of geography in there for you guys.
That's right. What hemisphere do you live in?
North.
All right, we're finding the volume of a hollowed out cylinder shown in
here it
terms
is.
of pi. Here we go. It almost looks like a hemisphere. Right?
That's right.
Okay, so we're it's kind of a little bit hard to see in that diagram, but we're hollowing out kind of a drum barrel head here out of a cylinder. And so the height of the entire cylinder is 2, and the radius of the cylinder is 2 also. So don't get confused with where we're going to put these 2's here. But we're just going to go through and find the volume of that hollowed out part. Okay, so the volume is pi r squared h. It comes from the volume of the cylinder, right? So we found the volume of the entire cylinder, and then we're going to subtract out the sphere. That would be the whole sphere, and so be careful there. We're going to we only have a half sphere, we only have a hemisphere, so that's where that half comes in. So we're going to subtract out that hemisphere from the entire cylinder. Okay, and so again, we really only have 2 things to plug in, the radius and the height. And so we're going to plug both of them as being 2 for this example. And so pi times 2 squared is plugging in the radius times the height of 2. Okay, just as Mr. Bedella said, that 1/2 times that 4/3 reduces. When you multiply those, they cross cancel to a 2/3. And then pi times 2 cubed being the volume of a sphere. Okay, so we just have to simplify all those 2's in there and keep those straight. So the first one ends up being a 4 times 2, or 8 pi. Okay, the second part there ends up being a 2 cubed is 8 times the 2 is 16 pi over 3. And so when you subtract those things, we end up having a volume of 8/3 pi cubic inches. Okay, and how would you say is the best way to try to picture what that looks like here?
Turn a Pepsi can over, and it's
There you
hollowed
go.
out on the inside right
Good
there.
example, yeah.
Yeah.
You turn that over, it's kind of dished in there.
Yeah, dished in there.
And so if it was cut off, it'd
Yeah.
be The pieces around that dish, kind of?
Yeah.
Okay, good.